Hello, grade 12 students. Welcome to lesson 1. And lesson 1 is about algebra, okay, specifically about simultaneous equations, all right? What am I using or what are we using? The book itself, Inquiry Approach to Mathematics, all right? And the question that I'll be talking about in this video is on page 30, okay? And that is number 10. So if you have the book, you can definitely turn there and follow along with me as you look at the video. Okay, so we have an equation there, okay? And the question is solve for x and y. All right, now I'm going to rewrite the question for us, or the equation. This is number 10. We have 4x minus 32 all square plus 3xy plus 48 square equal to 0. Okay, so far in your study of mathematics, you've been exposed to a system of equations. In other words, using two equations to solve for two variables or two unknowns. Today, we are learning how to use one equation to still solve for what? Two variables, all right? So this might be new to you. You may not be familiar with it, or you may have perhaps come across this type of question before. But in any case, let's go for it. Okay, so what are we gonna do? Definitely we're gonna perform inquiry on it. Okay, what are we given? We are given an equation. Okay, you need to be specific in inquiry. What is the problem? Okay, we are given an equation, and on the left hand side we can see that it is the sum of powers that are given, all right, and that is equal to 0. Okay, so that is exactly what you write in your what space under that equation. All right, you identify the problem. We're given an equation with the sum of powers on the left hand side, and then that expression is equal to 0, giving us that full equation. All right, so once you look at powers, definitely recall exponential laws. Okay, and here we have a particular type of power. The power there is 2, okay? And then we need to use what we're given, of course, to get to the solution of the problem, okay? So how do we start? We're given an equation, so we're gonna first work on the left-hand side and prove that the sum of whatever we do on the left-hand side will be equal to 0, okay? Because this is just 0, there's nothing much to do with that, okay? So consider the left-hand side of the equation. All right. So here we go. What is happening? Let's start with this expression right here, and then we'll move on to that one. Okay. So we have the following. I'm going to use blue for that. We know that 4x minus 32 all squared. When you are squaring any number, whether it's negative or positive, the answer will be what? Positive, right? And when you are squaring 0, what do you get? 0 squared is equal to 0. So we can, without any doubt, write that this is greater or equal to 0, okay? For all what? We only have one variable x here. So for all x element of real numbers, whatever value we put here, or number that we put for x, whether it's negative, 0, or positive, we'll always get that it will satisfy this inequality. The result will be positive, or it will be greater, it will be equal to 0 if we are squaring 0. Okay, so look at the next part. We have this as well. I'm going to use purple for that. We have 3xy plus 48 squared. Again, we're taking something. The base here is 3xy plus 48, and we're squaring it. And with the same reasoning, we can write that this is greater or equal to 0. But how many variables do we see there? There are 2, right? So we can say for all x and y element of real numbers. Okay, whatever numbers we put here for x and y, negative, 0, or positive, okay, and the result we square it, we'll always get a positive number, or 0 if the base is 0 of which we square. Okay, so far I believe you are with me. We are working with the left hand side, and we're going to prove that if we are summing this two expressions, then the answer will be equal to 0, and that is how we're going to get to solve for x and y. Okay, so since we have proven this two to be greater or equal to 0, let's take the first condition. If the numbers are both positive, if both of them are positive, can you add a positive number to another positive number and get 0? Definitely no. Okay, so it means we're going to work with the other condition where both of them are equal to 0, because 0 plus 0 will definitely be equal to 0. Are you with me? So now we are talking about the how. How are we going to do it? This is the introduction or the beginning of the solution. Okay, so then, therefore, if 4x minus 32 all squared plus 3xy plus 48 squared is equal to 0, this implies that 4x minus 32 is equal to 0, okay, and 3xy plus 48 is also equal to 0. Okay, both of them must be 0, because when you take 0 there, you square 0, you get 0. You take 0 there, and then you square 0, you get 0, and 0 plus 0 is 0. Okay, so then we have produced two equations that will then be, the basis from which we're going to work simultaneously to solve for x and y. So from here, we can clearly see that 4x is equal to 32. Okay, and division both sides by 4, what do we get? Therefore, x is equal to a beautiful 8. Okay, so that is what we have. We have covered this guy right here. We have solved for x. Okay, and in your knowledge and understanding so far, I believe that if you have two equations, you know that you must take the solution of the other one into the other equation. All right, simultaneously substitute and then get the answer. So then, how are we going to now continue? Let's call this equation 1. Okay, and then let's call this equation 2. All right, so proceeding from here, naturally we then move into this equation where x now is 8, and we'll just have a linear equation again with one variable y, and clearly we'll be able to solve for what? The y, okay, variable. So we substitute equation 1 into equation 2. All right, so what's going to happen now here is the following. We have 3 times, now the x right here is 8, okay, and then we still have a y there which we are about to solve for, and then it's plus 48 equal to 0. Okay, good, we are almost there, guys. 3 times 8 is 24, so we have 24y. Okay, because this 3 terms that we are multiplying, they give us just one term, a monomial, 24y, plus 48 equal to 0. Okay, and we can clearly see that from here, 24y is equal to negative 48, and we finally work out the value of y. Y is equal to negative 2. And there we are. And there we are with the solution. So this is what you will write under the how, inquiry question. how to solve the question is to consider the left-hand side, use, reasoning like this to say that a square of any number is always positive or equal to 0 if you're squaring 0. And from this, you can now mathematically come to this, that if you have this equation like that, it means you are having 0 squared plus 0 squared from this reasoning, and then you have produced two equations that will allow you to then solve for the two variables. Okay, so students, I believe that you've enjoyed this lesson and is clear for you to understand that you can still solve for two variables using one equation, because in the process of that you end up producing two equations, as you can see in red. That is how we answer such a question. So thank you for tuning in. I'll see you next time, which is next week for lesson 2, and I'll be talking about something else there. So right now is your turn to do the rest of the questions on the exercise, and yeah, it's time for you to go for the maths. Sharp, sharp. See you. Thank you.